Hello, it's Acacia Developer here, and today we're going to be talking about transferring data between different scripts in Unity. So the aim of this tutorial is getting you to be able to set and get values from other scripts, and we're going to cover a few different topics. So the first goes through public fields, the second goes through public properties, and the final goes through the static keyword. I recommend that you watch the entire video before asking any questions. Now in this tutorial we are using an analogy, and the analogy is going to be a multiplayer server. So we have multiple players that connect to a server, and we have an admin. And the admin wants to retrieve some data from the players. So of course the game isn't actually a multiplayer game. This is only an analogy to help beginners understand what's going on. So to begin with, what I'm going to do is create a new C# script. I'm going to call this script admin. I'm going to create another C# script and call this one player. Then in the scenes hierarchy, I'm going to right click and then navigate to create empty. I'm going to rename this empty game object to admin and then attach my admin script to the game object. I'm then going to create another game object, which is going to be a capsule. And since this represents a player, I'm going to rename this to player and then attach my player script to that. Then I'm just going to duplicate this a few times, and then that way we have more than one player. So these could represent individual players who have just connected to your multiplayer server. Each of these individual players withhold their own player script, which can withhold their own data. And of course we have our invisible game object, which has our admin script attached to it. And the objective is to get the admin script to modify and access data within the player scripts that are attached to these three player objects here. So first of all, we need some data for the admin class to be able to access. So what I'm going to do is declare some public fields in the player class. So this is an integer whole number, which will represent the player's health. We'll have a boolean, so this can either be true or false, which dictates whether or not the player is dead or not. And we'll have a float for the walk speed, and then maybe another float for the run speed, like so. Now as they stand, these fields aren't actually doing anything. Really, they're just examples of the kind of data that you may be exchanging between scripts. You may have noticed that each of these fields are appended with the public access modifier, and of course this is crucial because since we want to access all of these fields from outside this class, they require to be public. So in order for the admin class to access any data from the player class, what we need to do is access the data from an instance of the player class. So it would be private player. I'm just going to call this field player obj. So of course this is a field that has a data type that directly corresponds to the class that we've declared here. And that means that any object that is put into here is required to retain these four fields that we'll be able to access. So in the admin script, we'll actually be accessing these fields from our player obj. Now the reason why this field is private is because I don't want anything outside the admin class changing it or manipulating it. A problem with this though is the fact that it's not public, so it's not going to appear in the inspector. But we can actually solve this problem by appending an attribute, the serialize field attribute. And what that does is it makes sure that this field down here is always exposed in the inspector despite its access modifier. So once we come back to the Unity editor and we click on one of our players, as you can see, all of those public fields that we created in the player class earlier are now exposed in the inspector. And it makes sense considering they were all public, so they'll automatically expose. So what I'm going to do here is insert some arbitrary values. So I'll give maybe a health of 100, a walk speed of 10, and run speed of walk speed. So those are our values on this player script for this capsule object. Now if we click on our admin, on our admin script, we can see our player OBJ field is exposed. That was the one with the serialized field attribute. And of course, it's asking for a player. So what we can do is we can drag our player game object directly into the slot. What it's doing, it's going into player, and then it's finding this script here, and then it's putting this script into this slot here. So now that we've got that script object hooked up to our player OBJ, we can start accessing and manipulating the public fields. So I'm going to put this in void start. And remember that we're using player OBJ to access the fields. So if we go back to our player class, we have things like health, is dead, walk speed, run speed. So all we need to do is type in player OBJ dot. So we use what's called the dot operator to access the public field. And as you can see, IntelliSense tells us that there's a public field in there called health. There's also walk speed, run speed as well. And of course, our infamous is dead. What I'm going to do first of all is just print this to the console. So basically what these 4 lines of code will do, this will print the health of the player object to the console. It will print whether or not it's dead to the console, the walk speed and the run speed as well. So let's just save that and run our scene and just see how things go. As you can see, all of the values printed out on the console match up with the values that we inputted in on the inspector. And since it's the admin class that is printing this, we have definitive proof that the admin class is able to access those values. So far, all we've done is we've accessed these public fields, and what we're doing is we're just passing them in as an argument into this function that's printing it to the console. But what I want to show you now are the operations that you can apply to them, just to prove to you that you can. So you could do player.obj.walkspeed plus equals 0.2f or something. So you can add, you can also assign, so maybe I have a float for the new walk speed or something, and that's equal to player.obj.walkspeed, and then I can get my new walk speed and increment it or something. And also the same for all the other public members as well. So maybe sorry, I'm getting the name wrong here, is dead, we can set that to true. So we've now made the player die. And also maybe .health, we want to regenerate the player's health, or maybe we want to set it to something ridiculous like 400. Of course, this is actually going into another issue that we'll address later on with public properties. But really, this is just to show you that you're still able to execute all of the same operations and that. Even if, you know, player obj.isDead isn't within the admin class, we can still access it and we can still set it. And of course, we can still get values as well, like in this example, and then store it in this local float variable, and then we can do whatever we want with it afterward. So back in our player class, we can see all of the public fields that we've declared. Now, unfortunately, public fields are actually considered bad practice in C#. And this is because this public access modifier actually exposes the field to other classes in your program, and they can see all of these fields and they can manipulate them, possibly in an unexpected manner. And one of the key issues is being able to check whether or not data is invalid. So for example, if I'm creating a game where I wouldn't want my health value for any enemy to go below 0 or over 100, how exactly, using a public field, would I check that? Because any class could throw in any value. It could throw in 400, 4000. Of course, an integer data type can hold values way larger than 100, which is a problem. So ideally, what we want is a way to be able to check incoming data before we assign it to a certain field. And this is where properties come in. So to declare a property, I'm going to type public int, and then the name of the property is going to be health with a capital H, like so. Then in here we can put get. For now I'm going to put in here return health and set health equals value. And then up here our public field is now going to become private. So now this public property here has become the new interface for this private field up here. So I'm just going to show you quickly how to trigger the get and the set, and when these blocks of code are triggered. And of course, if we switch over to our admin class, our health is no longer seen. The admin class can't see it anymore because it's private. So instead what we use is the property. So in this case we're actually getting, because we're getting the value. So this is the block of code that's going to be executed when we pass this into our function here to print to the console. And of course that's going to return the value of this private field here. And then whenever we set, so that would be something like this, player obj.health. This is just going to be an arbitrary value that I put in, so we've just set it to 20. In that case, this line of code would trigger the setter here, and that would simply assign our private field with the value, which in this case would be our 20. Of course, as it stands at the moment, we're not actually doing any checks, so this property is sort of redundant at the moment. It was doing exactly the same thing as before when this was just public without the property. So I've deleted that code in the setter, and I've extended the pair of braces down so I have a bit more room to type my code. Now this is going to be the block of code that checks the incoming value. So like we already know, I'm just going to create an if statement, but the value keyword is what we use to get the incoming value. So that's whatever value this property is being set. So we want to check if it's below 0 or if it's over 100. This is the block of code that executes if the value is invalid, and in that case we want to do a debug.log error, and then we can say something like health is less than 0 or larger than 100. Or else, so this is a case where the value would be between 0 and 100, then we're alright. So we can just set the health with the value like so. So really that's just a simple check. So now in the admin class, if I go player obj.health is equal to 20, 20 should be valid because it's a number between 0 and 100. And as you can see, it doesn't complain, and it's printing out all this stuff like normal, and you can see it's changed to 20. Let's try and assign an invalid number. So first of all, I'm going to try maybe minus 1, and as you can see, it's created an error message in the console. Now if I set it to a really awkward number, let's say 101, as you can see, it's errored again. So to take things one step further, and just to show you the flexibility of public properties, we could say that, well, you have your isDead boolean, and when the isDead boolean is equal to true, then you want to play some sort of death animation. So you could check your isDead boolean every single frame, so you could check if it's true or false, and if it's true you then play the animation. What you want to do is check it every time the health is changed. What we can do here is extend these braces here. We'll still assign the health the value, but we'll just do a little if statement here. So if the value is equal to 0, then we know that the player is dead. So we can set isDead is equal to true. You could extend these, and then you could play your animation in here. So function call to play death animation or something. And really, you're only checking when it's necessary, and the only time that you should check would be when the health changes, not every single frame. In a way, I could have written this a bit better. So for example, if the incoming value was a negative, then I could clamp it to 0, and if it's over 100, I can then clamp it to 100. But really, this was just to demonstrate the power and flexibility of properties. They are really, really awesome, so use them. Now, one thing that I wanted to outline quickly, if you select your capsule players now, and you look at the player script for each one, you'll see that the health field has disappeared, and that's because we made it private. But what you can do in the player script is you can use the serialize field attribute like we did before, and this private field will still work in conjunction with your public property. It's just that it will now be exposed in the inspector as well. So that was just a little bit of advice if that becomes problematic for you. So there you go. So the health has popped back up in the inspector. So now we're going to move on to the static keyword, and I'm just going to retract this property because it's a bit too large. So let's say we wanted to give every single player the same walk and run speed. What we could do is type here static. So instead of public float, we now have a public static float. Now, many people get caught out with this because what the static keyword does is it makes this field a member of the type as opposed to an instance of the type. So if we go back to admin now, you'll see that walk speed is no longer a part of this object instance, which is our player obj. So instead, we now have to type player dot, and then you'll see our walk and run speed in there. Now this is the thing, you don't need an instance anymore, so we could delete this and delete these, and this would still work because, well, these fields are now a member of the actual type. You can see that we're now typing in player, which is the name of the class itself, and then we can access these fields. So however many objects we create from the player class, our walk speed and run speed are always going to be the same value, whereas a non-static field, such as this private field for our health, is unique for every single object that is created. So a lot of beginner programmers think that they can make fields and properties alike static because it seems to make it simpler to exchange data between different classes. But what they're actually doing is making fields and properties a member of the actual type, and in that case there's only one instance of that field. I recommend using the static keyword when you're dealing with global variables, so basically for any data where there's only one of it. So to demonstrate the static keyword, I'm just going to create a void start method, and in this start method all we're going to do is debug.log, and for now I'm just going to go for the run speed, like so. So notice, because we're actually typing this line of code within the player class, we don't actually need the player.runSpeed. This would be redundant. As you can see, Visual Studio is telling us that the name can be simplified, so we don't actually need this. So now what we can do in the admin class, in our void awake, so we know that void awake is actually called before void start. So if I get rid of this, we can simply set our player.runSpeed, let's say to 8.03, something quite specific. So the admin class is going to set our run speed to this value, and then our player class is then going to print that out. But remember, we have 3 different player classes because we have 3 different player objects, all with player scripts attached. So when we press play, as you can see, 8.03 is printed to the console, and we can see that it has been printed 3 times. If we click on claps here, that will uncollapse all of these so we can see all of the printed items individually. So the fact that we set the static property once and all of them have come out with 8.03 goes to show that our run speed value is the same across all instances of the player class. Anyway, that concludes today's video. I really hope you enjoyed and learned a lot, and like always, I shall see you soon.